This contingency table problem has great applications in healthcare as it's a way to examine the false positives and negatives and really look at the accuracy of this test for all people involved. Here we have 4 different groups of people represented, and we'll have 4 questions about this looking at different conditional probabilities, which are really important to studying dependence. I'm going to look at this in both Google Sheets and Stapplet to show you a couple methods of getting these answers. We'll also compare the notation to different ways that these could be worded. You see, sometimes we have notation, sometimes we have these questions. The first one given in notation is saying, what is the proportion of these people, or what percent of these people, or we could say, what is the probability of selecting a person who got a positive result given that she's pregnant? Or we could say, out of the pregnant people polled or surveyed, what percent or proportion had positive results? So we can word it either direction using different language and syntax to convey that meaning. Many people will say probability of positive given pregnant. I like to think of it as out of the pregnant group. So out of the 56, we have 50 over 56. And over in Google Sheets, I can do that. I'm going to copy and paste this notation. Notation's helpful here because I don't want to have to write that whole long sentence. I'll write it as both a fraction, 50 over 56, and I'll use an equal sign to get a precise probability. You can do rounding with a round function, or you can use these arrows. Going left here really means we're going to reduce that number of decimal points to get a nice precise answer that's rounded appropriately for the problem. The next one, we will do a different probability. That one is the probability that the woman is pregnant. So this one's probability of pregnant. That would be the first thing in that parentheses. Given is that vertical bar, and the test is positive. So we're just flipping these two around this time. And it's not just flipping around the fraction. That's a very different thing. It means that instead of examining the pregnant row, we'll examine the positive column. We'll be saying out of this column of people who got the positive results, what fraction were actually pregnant? Well, it's the same group of people that we're examining, and that's the intersection, but we're looking at a different total. That should be 50 out of 59. And I can round that too. For the third question here, we have a given, again, given that she's pregnant. What's the probability that the test is negative? So that would be a false negative. Given that she's pregnant, that's after that vertical line. So we should have probability negative given pregnant for our notation there. Out of those who are pregnant, that's this row, we've got 6 negatives out of 56. The rate of false negatives then is a little under 11%, I should say. 11% of the tests that are taken, 11% of pregnant women, I should say, that was our group that we were looking at, get a negative result and have it as a false negative. We could also look at what percent of negatives are false negatives. If we want to look at it that way, that would be similar to this last one. If I looked at the proportion who are pregnant given a negative, that would be a false negative. I'm kind of curious about that one. That proportion out of the negative results, we have 6 out of 75. So if someone got a negative result, they could still count on the fact that there is a chance, specifically an 8% chance, of getting that false negative. But the last question was asking for something different. It was a proportion or probability for not pregnant given negative. We're going to have 75 in that group, 69 out of 75. Should be 92% because that is the complement of the last one that I got. That will give you a bunch of different conditional probabilities. We can also double check these with Stapplet. Now with Stapplet, there's a specific way we put this into one categorical variable, multiple groups. We want the explanatory variable typically to be in group 1, and then the response variable to be the categories here to really show the results the best. So we may not always align with what we're given. I'm going to do this the way that it's shown just so I have it aligned and matching up perfectly. So there is the table that I started with and what I entered into Stapplet. Now, this is what would be affected largely by the way that I enter things in. We see here we're grouping by the test result. And so I could say pregnancy test results actually is a better label of the group, not the results. This would be a pregnancy status by results of test. It's kind of an odd thing to look at a graph of, especially arranged this way. I find that many of the problems that we see in the homework specifically or in different areas, we have a flip of row and column from the way we actually want to analyze it. So it might make sense to flip these around, but I'll keep them as is and show you what we get in our results. We get a lot of percentages for free. We get the percent in the margins or marginal probabilities for those. And then we get conditional probabilities throughout the middle. So for example, this one right here, we're getting 50 out of 59 is that 84.7. That is the proportion who are pregnant given that they got a positive result. Now let's check the answers that we had in Google Sheets. There's our probabilities. So the probability of a person being positive given they're pregnant, I don't have that one because I don't have marginal probabilities to the left and right. The only one I could do is the ones that have a conditional given that they're positive or given that they're negative. So I could check this one. That 84.75% is right below that 50. We see this 8% and 92% here and here. So we can see of the positive results, the proportion that are true positives versus false positives. Of the negative results, we can see the proportion that are true negatives and false negatives. So those proportions will come in handy in that way, although I just don't know how useful some of these plots are going to be for this specific application.